Good day, listeners, viewers, students all over the world. I remain Sir LUMAJ. Our last video, we were talking about Act A, but we couldn't finish it. So today, I'm going to continue from where I stopped. Like I told you, chemistry, physics, maths, English. So simple. I'm a professional. So something simple. So just follow it, you're going to get it. So last time we were talking about molecular formula. I told us how to derive methane or how to derive methane. Don't forget, principle is universal. Whatever they did in the past, we can still do it now. Can we do it better? So methane, I gave us the general formula CnH2n plus 2, and we derive that when n is equal to 1. So if A, C2H6, I told us how we got CH3CH3. And for this, okay, let me go to propane before I talk about the structural formula. For propane, we have N to be equal to 3. Don't forget CnH2n plus 2. So it becomes C3H2 into bracket 3 plus 2. So we have C3H6 plus 2. That is what? C3H8. Propane is what? C3H8. Don't forget you're going to do the following, the rest as your exercise. So we have C3H8. Let's go to the structural formula. Then the structural formula of this, and I will also like to explain homologous series with this from what I gave us there. To write the structural formula of CH4, we have C obeying the law of what? Tetravalency. You have hydrogen, hydrogen here. I said don't forget, when you see a single line, it means a pair of electrons. So this is a single bond, or you call it sigma bond, and it's a very strong bond. The sigma bond is stronger than pi bond, don't forget. So we have C having 4 hydrogen atoms surrounding it. That is what? The structural formula of methane. Now, if you want to write for ethane, ethane is what? 2 carbon to carbon, single bond. Then, law of tetravalency. Each carbon atom will be surrounded with what? 4, what do you call it? Bonds. 1, 2, 3, 4. Then, introduce your hydrogen. Introduce your hydrogen. Introduce your hydrogen. If you count 1, 2, 3, 4, 5, 6. What do you have there? 6 hydrogen. And if you want to collapse it to molecular formula, don't forget the way I explained it. That will be what? C 1, 2, 3. C 1, 2, 3. H3. Is that clear? So for propane, we are going to have, carbon to carbon first, single bond. Then the third one, so either you add it to the front or you add it to the back. Now, obeying the law of tetravalency, if you look at this carbon, you already have 1, 2, 3, 4. 4 bonds are surrounding this carbon. Come to this carbon. 1, 2, 3, 4. Law of tetravalency. Come to this one. This is 1, 2, 3, 4. Then introduce the hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8. What do you have here? C3H8. You can also write it this way. Look at this is carbon, C, 1, 2, 3, H3C. You have CH having how many hydrogen atoms? 2. Then you have C, 1, 2, 3, CH3. So in some textbooks, they can write CH3, CH2, CH3. In other textbooks, they can write H3C, CH is still the same thing, provided you have your number of carbon to be according to the H2n plus 2, the molecular formula. So they have to obey what? The law of thermogenesis. And meanwhile, by the time we start talking about reactions, you understand that. Here, they will only use this for their reaction. That's why I told us that alkane undergo substitution reaction. You can't break this one. You can't break it. They only substitute with another atom to generate another one. And moreover, I said I want to talk about homologous series differ by CH2. Don't forget, where we have met A, CH4. CH4, homologous series differ by CH2 plus CH2. This is simple arithmetic. How many count do you have here? 1. How many count do you have here? 1. 1 plus 1. That is 2. How many hydrogen atoms do you have here? 4. How many hydrogen atoms do you have here? 2. 4 plus 2, making 6 hydrogen atoms. So, if you go, this is met A. What have we gotten? We have gotten, or let me put it this way so that it can be very easy or clearer. You have this to be C2H6. C2H6. This one is what? It's A. If you now add C2H6 plus another CH2, what do you have? C2 plus C, it will give us C3. H6 plus H2, that is H8. We have gotten what? Propane. And that continues like that. That means we can have C3 plus C3H8 plus CH2 to give C4H10. And this is what? Butane. Homologous series differs by CH2. Met A differs by CH2 from what? Ethane. Meaning that if you add CH2 to methane, you're going to have ethane. If you add CH2 to ethane, you're going to have propane. If you add CH2 to propane, you're going to have what? Butane. That is the meaning of what? Homologous series differs by CH2. I want to believe that is very clear. Also, the structural formula. The next one I want to talk about is the alkyl. Before I will start talking about the reactions and naming of those compounds. Alkyl. You know, I promised that I was going to do justice to both alkyl and alkane. Alkyl group. Alkyl group, basically they are attached group. And they have the molecular formula of CnH2n plus 1. It's just one hydrogen deficient of alkane. One hydrogen removed from alkane group will form alkyl group. And alkyl group, basically, they are what? Attached group. Attached group. They form attached group to a compound. You so understand. Now let's go. You know, serial number, you are going to complete it as an exercise. Serial number, we have the chemical name, we have the molecular formula, then we have the structural formula. So on that serial name, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here, instead of, if you don't forget, the other one, I mean alkane, when I wanted to write it, I wrote methane. And I underlined this. But this is not methane. I told you that it is one hydrogen deficient. So what is other hydrogen deficient is no longer going to be methane. It is now going to carry this alkyl functional group. So it will now be methyl. So that what differentiates alkane from alkyl. One hydrogen atom deficient. So we now have methyl. So the next one, instead of we have to have it's A, we are going to have ethyl. Instead of us to have propane, we are going to have propyl. Instead of having butane, we're going to have butyl. You can fill the rest. So molecular formula now, when N is equal to 1, we're going to have C1 H2 into bracket 1 plus 1. So that will be what? C H 2 times 1, 2 plus 1, 3. So this is now what? CH3. So if you want to write the structural formula of this, the structural formula of this can easily be written as C. How many atoms? Don't forget the law of thermovalency. 1, 2, 3, 4. How many atoms do you have here? 1, 2, 3. You can see this site is vacant. It is this site that they are going to use to attach to another compound. Maybe either with by a substitution reaction or addition reaction. Is it clear? Fine. So I will need you to do ethyl, propyl, butyl as your own exercise. The next thing I want to do is naming of arcane. Naming of arcane. Naming of arcane. Naming of arcane. Naming of arcanes. How do they react? How do you name them? 1. You locate the longest continuous chain. Locate the longest continuous chain. Then 2, you assign to the lowest carbon atom. 3, follow the alphabetical order in numbering. I'll just give us an example to explain all this now. Now look, I said, let's say we have this C, 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 C. Maybe I have this CH3, hydrogen, this is an organic compound. Sorry, this is an hydrocarbon. Carbon and nitrogen only. If you now look, I said locate the longest continuous chain. Carbon continuous chain. This is carbon. Don't forget your 1, 2, 3. You do it ascending and descending order. This is numbering front 1, 2, 3, 4, 5. Is that a carbon? No. Then you go backward again. 1, 2, 3, 4, 5. Do you have any branch? Yes, there is a branch here. If I go like this, 1, 2, 3. Now look at it. What's the length of that carbon? We have 5. Is there anyone that will be greater than this 5? This 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Ascending and descending order, we got 5. But if you follow branch, 1, 2, 3 is lower than 5. If you go like this, 1, 2, 3, 4, 5. It's either we count 1, 2, 3, 4, 5, because this also gives us what? 5. It's either we count like this, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This, if you count 1, 2, 3, 4, 5, this one will now become an attached group. It will be CH3. But if you are looking at the straight chain, don't forget, I told us that acyclic aliphatic hydrocarbon can either have a straight chain or branch. Here we have straight chain and branch chain. If you count like this will become a branch chain. If you count straight, this will be a branch chain. So we can take any of the two because they are giving us the same 5 as the number. So if I count straight, I will have 1, 2, 3. Don't forget, root 2 assigned to the lowest carbon. Which one will give us a lower carbon between the two? This is 1, 2, 3, 4, 5. You circle it. You circle it. If you are counting from here, 1, 2, 3, 4. The first place you have the attached group, which is methyl, is on carbon number 4. If you are counting from front. But if you are counting from back, this is 1, 2. You have the attached group to what? Attached to the carbon number 2, which is now smaller, 2 or 4. The rule says assigned to the lowest carbon. So this is the lower carbon. So we are going to count 1, 2. So this 1, 2, don't forget this is CH3. This CH3 is an alkyl. Alkyls, they are attached groups. So for you to now name this compound, or yes, it should now be 1, 2. This attached group is on carbon number 2 from this rule. So it will now be 2. What do you have on carbon number 2? Methyl. 2 methyl. Then how many carbon do you have in your straight shape? It will now be 1, 2, 3, 4, 5. So which alkane has 5 as its number? That is what? Pent-A. So the name of this compound is what? 2-methyl pentane. 2-methyl pentane. In our next videos, we are going to be having lots of exercises or I'll give you some questions, we'll solve it together. But make sure you subscribe to get the next video. I told you chemistry is very simple and I'm very sure you are enjoying it. Subscribe, share it. Thank you.